All right, here we are, everybody. Welcome to another episode of the Filter That podcast. Today, we've got a pretty hot topic, explosive, if you will. We're going to be talking about all things related to combustible dust and how to avoid a dust explosion. We covered this last year, sometime between, I think, July and August. I had a great webinar, and Alysha and Adam are actually here with us again. So, welcome. How are you guys doing today?
Doing great.
Very good. How are you?
Thanks.
Excellent.
Thanks for having me.
Yeah, we're glad to have you, like in the flesh, in person. Well,
quote unquote.
Virtually anyway. Yeah, exactly. So let's get started with you telling us a little bit about yourselves. I mean, I know Adam as I don't know if they still call you the filter bomb stopper out there in the marketplace or not, but tell us about yourself and tell us about CTI.
All right, filter bomb stopper. I'm gonna have to get that on a nameplate somewhere. So yeah, my name is Adam Haroz. I'm one of the engineering managers here at CTI. We're based out of Atlanta, Georgia, which allows us to pretty much travel anywhere as long as Delta gets there pretty easily.
Right.
CTI's environmental and safety engineering consulting firm. Been in business since 1986. And we work with general industry, primarily manufacturing, for all sorts of compliance.
Well, if you were at remember when we all used to have large dinner parties and like we could invite tons of friends over? You remember that, Alysha and Adam? No, never happened actually. I mean, if you were at a big party like that, and you had to go around the table, and like there was 10 people that went in front of you, what back when those actually happened, of course, and you get like 3 to 5 words to tell everybody what you do and to make a decent impression, what would you tell them in 3 to 5 words of what it is that you do?
3 to 5 words. Environmental and safety compliance for manufacturing.
All right, that's pretty good.
Yeah.
That's pretty good. I like that.
All
right, Alysha, of course it's your turn. Thank you, Adam, for the introduction.
Yeah, so as you said, my name is Alysha Yinger. I am the Director of Engineering at RoboVent. I kind of have an overarching view of pretty much everything we do here at RoboVent, including the product design, project, system design, installation, just kind of have a hand in a little bit of everything. At RoboVent, we are a dust collection company. We handle everything to do with particulate and all sorts of industries, and we deal with the front end side of it of, okay, I have a new system, I have particulate generation, how do I protect from that? All the way down the line of how do I get that installed? What are the best designs? Oh no, I have a combustible dust. What do we do now? Handle all of that.
I'm going to ask you the same question. What would you tell folks? What is it that you do?
I think I'd say that I keep people's lungs safe.
Which sort of ties in with our natural tagline of making a difference one breath at a time. Well, I'm glad that you're both here today and agreed to sort of redo our webinar in more of a podcast format and have a little bit of fun with it, and of course educate people at the same time. I feel like I need to start the show off with a really bad dad joke, but it relates to dust collection, so you guys play along with me here. But
I love dad jokes.
Why do most manufacturers prefer RoboVent systems and equipment over others?
Quality?
Well, it's because others combusted.
Wow.
Did you come up with that all by yourself?
It's my first dust collection joke.
Wow.
I did. I wrote that one. I think I'll have to trademark it.
That's a very specific dad joke type. I'd like that.
My son's like, that's not funny, Dad. Actually, it's not funny at all. I thought you were going to tell me the one about the mustache. I'm seriously on fire. I mean, sorry, not fire. I just had a thermal event. And I'm just busting your chops so we can get on with it here.
You're quite punny this morning.
I'm always punny. In addition to our regular topics, we've actually got a fun segment later where we call it the F-bomb, or the filter bomb, if you will. That's why I called Adam that earlier. We're going to show pictures on screen, and our experts here are going to be circling the hazards that they identify in those pictures. And then if we get folk to submit some to us, we'll do the same and do that on one of our follow-up episodes. Help people understand just generally speaking, and Alysha, I'll have you go on this one, and Adam, if there's anything that she misses, feel free to chime in. But just what is combustible dust? Let's just answer that for maybe somebody who is tuning into this show for the first time. They don't know anything about dust collection, industrial ventilation, hazards.
So a combustible dust can be any particulate that is combustible, and I hate to use the word in the definition of that, but it is a dust that can explode, and it can be from a general process, it can be raw material, it can be a variety of things in a manufacturing environment. And Adam, do you have?
Yeah, I mean, I think you hit it. We can get into, I don't need to define it by going into the specific scientific, but it's basically a combustible particulate, a combustible being an explosible particulate that reaches certain levels that has the hazard of either producing a pressure wave, a fire, or explosion that's released in the air at a high enough concentration to deflagrate or something like that. So I just really enjoy that word as part of the definition, and that the particles are so concentrated in the air that one particle catching fire just spreads rapidly, and it's a rapid release of energy.
I'm pretty sure that deflagrate is what my uncle does during holiday parties.
Yeah.
So I think we're here at the same time right now, but I'm going to ask you both a question, and I want you to answer it at the same time. What is by far and away the number one mistake you see manufacturers make, or maybe the number one thing that you have to address out in the field as it relates to combustible dust or maybe system design for prevention? So think about that for a second, and we're going to go. Ready? 1, 2.
Not doing a DHA.
What was your answer, Adam?
The attitude of some of the workers or facilities.
Okay. Attitude. So maybe like the general approach that folks have. Alysha, you're saying like just not even analyzing things in your facility and doing that analysis. And Adam, you're saying what's really just the approach that folks have or the mindset.
The mindset. Yeah, I think they're they definitely go hand in hand, actually. So, like when I say attitude, we've been doing this since 1971 and we've never had an explosion, so it's not going to happen here.
It could happen to you, right? I mean, the most famous or infamous dust explosion almost of all time, Imperial Sugar. I mean, the amount of footage and video and system design that's surfaced as a result of the investigation. I mean, there was substantial loss of life, substantial damage, and that was a big issue. And some of there was communications that went all the way back to I think the 50s or 60s. I'm not an expert like the two of you. And is that what you mean?
Something like that. So Imperial Sugar, 14 fatalities and a crater in the ground, and it all stemmed pretty much from an enclosed conveyor with a messed up hanger bearing. So you get that attitude of, well, we've been doing it this way for forever, so it's not going to be a problem. And that stems from their lack of PMs, their lack of housekeeping, their lack of overall investigation, their lack of training. When I do a DHA, I might be asking very specific questions, looking at one item at a time, but it kind of taking in all the facility and culture has to offer. So, and then that stems from them saying, well, I don't want to do a DHA. I don't think it's necessary. And that comes to Alysha's point. And then it gets, well, is it required? And that I'm sure stuff we'll talk about later. So I think they all kind of tie together.
That's a great point. Alysha, you said right out the gate, the DHA. Why that? Why that part?
Because really it's your first step of analyzing your hazards. That's what it is. It's taking that overarching look at your facility and saying, am I at risk? Are my employees at risk? And if they are, how do I protect from it? And we find more often than not, people just don't want to go through that process. Maybe they don't want to hit it head on, or maybe they don't want to fully look at all of it. Or like Adam said, maybe it's just, well, it hasn't been an issue yet, so why should I go through this process? But in reality, it's a safety check. It's just that gut check that everything you're doing in your facility is the best you can do for your employees. And it's a very simple, well, not simple, but systematic approach to doing that.
Keeping your employees safe by at least identifying the hazards to know if you need to fix or if everything's okay. I mean, I've done DHAs with minimal recommendations or an procedural recommendation, and then I've had some that are going to require a lot of capital. So you need to know what's going on before you say it's fine.
Yeah, and that's important too. It's not always that a DHA is going to result in this some huge amount of capital. It could come, nothing could come from it, or just an understanding that what you're doing is good or enough, or just identifying some things, maybe help with PM or housekeeping or this or that. That DHA is really just pointing out everything for you.
And I actually have a decent example of something like that. So I did a DHA where they had all new dust collectors put in for their unloading area, where the trucks unload grain into the pits below. And I'm doing the DHA, protection on the equipment, relief panels, isolation, everything looks good. And then as I'm walking around the dust collector, I noticed that the 2 explosion relief panels are facing each dust collector. So they're literally facing each other. So then I said, well, they just bought one and then bought a second one, not knowing where they were going to put it. And I'm like, so that means if one issue happens, it's going to spread throughout the whole system. So the DHA just showed everything was fine. You protected it, but your protection is actually now introducing a new hazard. So without that DHA, they'll say, oh, our dust collectors are protected. So if we have an explosion or a deflagration event, we're fine. But really, if one pit blows, the protection will blow into the other dust collector, spreading it through the other line to go into the other pit. So,
right. See, and it's really interesting that just with that question, having you answer at the same time, you both took a little bit of a higher level approach, and that's like the germane theme that surfaces when you talk about these things with our manufacturers. And you didn't mention a very specific hazard, because there's so many different things that could be part of the equation that causes a major issue within a plant. But seriously though, what was all the hullabaloo back in September? There was this big deadline. You had a ton of companies saying, "Hey, September 7th is coming. Make sure you've got your ducks in a row." Mm-hmm. What was the hullabaloo about September 7th last year?
So I can answer that, having put out a lot of statements on it. So September 7th, 2020 was the deadline set in the NFPA 652, the National Fire Protection Association, 652 being the overarching standard for combustible particulates. September 7th, 2020 is basically when they decided is the deadline for all general industry manufacturing with combustible particulates that's not governed under NFPA 61, which is food and agriculture. So all metal fabrications, wood, pharmaceuticals that have combustible dust need to have a DHA conducted by September 7th, 2020. That's the big push from last year. I think then obviously COVID came into realm of everyone's life, and September 7th was still set as the deadline. It never changed. There's just a whole lot of interpretation about that.
Sure, sure. And people have been now arrested right on the spot, right in facilities. OSHA comes in with handcuffs, huge paddy wagons, and just puts the staff right in there, right? As they get ushered out
I've
of the
seen some
facility.
crazy OSHA inspections, but I've never seen them with handcuffs and a paddy wagon. So
No? Oh man.
yeah.
I guess I've not had to be part of a OSHA inspection myself directly. That's not
No, and Alysha,
my
I don't know if you've dealt with the OSHA inspections, especially related to the particles that your customers might handle, but no, OSHA's not. So it's a complicated question discussing the enforcement of that September 7th deadline. So I will say that, OSHA's not particular. This is all, nothing's going to be like really written down in stone, but OSHA's not exactly enforcing that September 7th deadline, because that deadline's in the NFPA standard, which is a national consensus standard, and OSHA can only cite based on regulation, which is law. So anything in 29 CFR 1910 for general industry, let's say. So they're not particularly enforcing on September 8th. They were hammering people. It's more of, if they show up on site and you haven't done a DHA, they'll definitely ask you to do one in their time frame, and they'll probably want to see it. I have seen OSHA citations from federal and state OSHAs for not having a DHA conducted. It's just then the citations and fines can be negotiated after that. But they can still cite for violations. They do have regulations that cover that, whether it be housekeeping, fire, electrical. If you're under PSM, this OSHA regulations on that. So it's not that they're going to arrest you on September 8th, but they know it existed. And for anyone that's food and agriculture, that deadline is January 1st, 2022. So that's also approaching.
Alysha, I don't know if you've got some experience with the different regulations as well, or because I know that we work with Adam and his team a lot to actually perform the DHAs, and we're more on the system design side. But do you have any additional commentary there?
We have worked with a lot of companies through a lot of OSHA audits, or when sometimes companies even seek out an audit. They say, hey, will you come in and kind of just given us an analysis of this building? We want to get ahead of it. And we have worked with companies through those. And no, they're not citing NFPA specifically, but they are looking through it. They are kind of talking about those points and bringing them up and kind of working with the customers through the NFPA standards. So,
and Alysha, with what you said, you guys, I am sure we'll be seeing this more and more, but it's become more commonplace for us to get invited on site to do a DHA, because the fire marshal is requiring it before they allow building permits. And that's if that fire marshal is using updated NFPA standards. Some, maybe a rural community here in South Georgia might be using an outdated NFPA standards, but some of the newer ones, especially in major cities, are requiring DHAs be done before they allow building permits. And that's also very similar. Insurance companies are requiring their facilities to do it before they allow full coverage. So I'm sure you guys, I know it's been trickling in with some of your customers, but that's actually the more commonplace that I've been seeing.
Yeah, and insurance companies are a big one. Insurance companies, just whoever they're working with, wanting that documentation completed and submitted, for sure.
Before they decide to insure. So obviously we know the issues around the dangers of the explosive dust, but there's obviously financial and legal consequences and preparation that you need to do all across the board throughout the process, even sometimes just to get your permits, as you're saying. So, in all of this, what role does the dust collector play in the prevention of an explosion? I mean, Alysha, can you speak to that? I mean, how can it make the explosion worse? What are some of the safeguards someone could use within the general equipment design to, either mitigate or prevent a potential hazard and explosion? Can you talk us through that a little bit?
Yeah, so often when we think about a dust collector in an industrial space, we think that that is a safety piece of equipment. It's there to help us. It's there to get that particulate out of the air, out of your employees' breathing zones, and into a safe, confined space. But when you have the combustible dust, safe, confined space takes on a new meaning. So the dust collector in itself actually becomes a area in your facility that you do have to protect from that explosion. When you think about that explosion pentagon, everything that's needed in order to create a combustible dust explosion, you have the ignition point, the dispersion, the confinement, the dust, and the oxygen. All of that is inside of a dust collector. So what we do, or what happens after DHA is completed and that risk has been pointed out and we know that we need to do something to fix it, is that we go and we protect against it. So we add those deflagration vents, the isolation valves or no return valves, and the rotary airlocks. And we do everything we can to keep that collector safe. So when an explosion were to happen inside of the collector, it would not propagate through your facility.
Adam, are there specific are there issues that you see with more regularity in the field? Because we obviously work on our own equipment. We're installing our own designs. You sort of get a nice broad stroke across the industry, and you've seen a lot of different system designs. Are there specific hazards within that type of design that you see more frequently than others?
Yeah, that's actually a very good question. And with what Alysha said, the dust collector is kind of that perfect storm. Everything that could go wrong is happening in that controlled environment. And it's funny you asked this question. The NFPA just put out a really good research document or technical document about combustible dust hazards in dust collectors. And they found the last 10 years, 42% of combustible dust incidents occurred due to a dust collector. So when I'm on site, the dust collectors, we take, we definitely take our time. We look through it. If somebody says, like Alysha mentioned, a rotary valve, like if the dust collector discharges through a rotary valve, for it to be considered a rotary airlock as a form of isolation, you need that close clearance between the paddles and the casing. So that's something we would look at. And are you ensuring, or do you have PMs to ensure that close clearance as required by the standard? The other thing that I said, I mentioned even when people put protection, to make sure the protection is appropriate, or if like I talked about those panels that were facing other dust collectors. But the thing about dust collectors, it's one of the most widely used pieces of equipment at a facility because it tends to pull from multiple process lines. So even if one whole set of equipment is down, that dust collector is still working. And then dust collectors being used for the whole area versus what's the potential for tramp metal to get in there. I go to a lot of food facilities where I just point out, like, I'm wearing my wedding ring. If I'm dumping a bag, who's to say this ring's not going to fall off my finger and create sparks in the dust collection line, things like that. So those are pretty much some of the bigger items I see. The design of the dust collection system is extremely vital. Did they take the duct sizing into account based on the explosive concentration of that material? Or did I know you guys do this because I've had conversations with some of your sales staff, your engineers, and even Rick a little bit of, was the material itself taken into account when designing the dust collection system? We've talked a lot about welding fume dust. So, that's one thing that's coming out we're seeing it as explosible. So it was the welding fume dust properties as well as welding as the process itself taken into account in the design. So those are things that's a little more kind of down in the dirt of the design and the drawings and the calculations. But that's something that I'm seeing more and more and more, especially with metal dust. That again, we're trying to change a typical outlook in the culture of that. So hope that answered
Sure.
your question a little bit.
No, it does. I mean, Alysha, is there something specific that you sort of see with regularity out in the field? Maybe top one or two?
Yeah, and Adam brings up a great point. It's not just that you have all of the elements that go into protecting a dust collector, because it's a lot more than that. It's, are you using them properly? Are you sizing that vent properly? Are you facing it in the correct direction, as Adam has pointed out? We see very often that companies will use an isolation valve or a no return valve, which would be what prevents that explosion from re-entering your facility. And they'll have one, but has it been applied to the system in the correct way? So have they read through that manual and understood the distance it needs to be from the collector, how many elbows you're allowed to have in front of it or behind it? Those are the little nuances to kind of ensuring that your system is compliant that tend to get overlooked.
I love that you brought up weld fume earlier too, because there's, we're going to have some discussion around that continually about the combustibility or explosibility of weld fume. So I think, I was going to ask you a question about what you felt like the biggest faux pas were in the field, and I think you've both done a nice job answering those.
I got plenty more.
Have you? Well, we've only got a few more minutes today, so we'll keep that for another episode because there's a lot to cover here. Out of curiosity, has there ever been a dust explosion at a plant at which you've done a DHA, years later, or were you there as a result of the explosion?
Yes. When there is an explosion, we know of some facilities that we've worked with or performed DHAs where there's been an explosion, deflagration, or fire. I would say most of the time that explosion typically happens within protected equipment. So, for an example, I did a DHA at a grain handling facility, and before I even finished the DHA report, there was an explosion in their bucket elevator. So it was kind of one of those, the stars aligned for this explosion to happen, in that it was caused by a bearing on the head section that got overheated due to friction because a bird had started making a nest on the shaft and had pulled a piece of drive belt. So the rubber was hitting that bearing, which overheated, which caused the explosion. So my DHA pretty much got amended to incorporate the alarm system they have in place, because it was kind of just a notification alarm versus a full shutdown. But that explosion happened, but they had explosion relief panels every 20 feet up the casing. So the bucket elevator blew, but it vented properly as it's designed. So all that had to be done was repair of the bucket elevator. I think the total cost was about $25,000, but for a blown bucket elevator, it would cost a lot more to replace the whole thing. So that's one incident that happened, but it actually vented properly. So, fires and explosions happen. They happen. But if everything's protection and venting is where it needs to be, it's going to severely mitigate any potential risk to equipment or people.
Well, not case in point, but I think, that highlights the benefit of performing the overall DHA, so you have a broad scope and understanding of all your potential hazards, right? It's the hazard analysis. And so it's really then up to the manufacturer to prioritize those things, understanding what the risk factor is of all of them, and maybe addressing them one at a time. Or they may decide, we don't feel like there's much risk here, so we're actually not going to do anything, but at least we know what our risk factors are and we're assessing those values.
And at least identifying. So, I mean, DHAs are required to be revalidated every 5 years. And I look at that 5 years, kind of that perfect time span to say, if I give you a list of recommendations to be compliant with the standard and mitigate potential risks and hazards, well, you have a time period. It's not like everything has to be done next month. Some things require capital or resources or time or ordering signage. I mean, you have the time to do it, but you need to identify what are my priorities, what's easy, what takes a lot of money, what can I request as my capital for next year. So you need to know what you need before you say, I don't need anything.
Right, and obviously if the dust collection system is part of that, or you need new dust collectors, or they need to be modified, I mean, that's typically a capital expenditure, so that needs to go through budgeting processes and things of that nature. Signage and maybe other things that could be placed in and around areas might be pretty easy to do, a couple $100 or a couple $1,000 depending on what you need. That's interesting. Performing the DHA is just not a fail-safe. There's typically action items from it. It's not like, oh, I've done this, great, I'm done, I don't have any further action items.
It's not a checkbox on a to-do list. It's a big project to just have the DHA done, but that's just the beginning. I mean, that, like I said, hopefully it's a company culture that they want to be safe and want to protect their equipment and employees, but that's besides the point. It's not just, okay, I did the DHA, see you in 5 years. We make ourselves available to discuss the recommendations or engineering changes or review of drawings or.
Let's see here. We talked about why the September 7th deadline was so important, but what's coming in the next couple of years or next 5 years? What's the next big thing or deadline that's coming that manufacturers need to be well aware of?
Yeah, I mean, it's part of my job to really just keep on top of it. Plus, at CTI, we are on some of the NFPA committees, so we try to keep our ear close to the ground for those. But there are a few things, like I said, the NFPA 61 deadline, which is for facilities that deal with combustible particulates in food and agriculture. Their deadline for DHAs is January 1st, 2022. So that's the big deadline. NFPA 484, which is the standards for metal dust. I'm expecting they should have an update of the standard by next year, which means it'll come out later this year. So their 2022 standard that comes out at the end of 2021 is expected. I don't expect that many changes to the standard. If anything, it'll just kind of be more incorporation of NFPA 652, which jumps to my other expectation in the next few years is, NFPA is really trying to pull everything together into one centralized standards. So like NFPA 652 being the overarching standard, they don't want an NFPA 61 and 664 as the commodity specific standards. They kind of want those as the appendices of a major standard. So I think they're tentatively looking for that to become NFPA 660. We'll see. I expect that by 2024 is maybe the first draft will come out later this year, but it's been on their docket for quite a while, so we'll see.
So I think I'd like to move us into our segment, the identifying the filter bombs, as we called it earlier. I'm going to pull up a couple of images on the screen. Alysha, I'll have you go first. These photos up here real quick. So for folks that are new to the show, we've got a little segment we have here called the F-bomb, the filter bomb. And we're going to show pictures of a plant that it doesn't have any attribution to any particular manufacturer. And we're going to identify some of the potential hazards that you can see in this photo. Now, I'm going to go first because I think I can identify a couple of issues with this particular photo here. As soon as I saw it, I immediately identified one, but then I'm going to kick it over to you, Alysha. So let me see if this formatting works here. Okay, you should be. I'm drawing on my screen here.
Mm-hmm.
So the first thing that I see, because we always talk about an ignition source, right, which could be any sort of, spark, flame. The laser beams that are shooting from whatever's on the back here, I feel like could potentially be an ignition source for some of the dust that's obviously floating around this area. Adam, has a laser ever caused a dust explosion?
So I've never heard those referred to as laser beams. So those are backup lights, actually. They shine about 8 feet behind the truck. I would
What?
say it's tough. Sometimes it's tough to identify the ignition source from an explosion, but I'll give you benefit of the doubt and say correct. This whole forklift is. I lost the picture. The whole forklift is actually the issue. So I don't want to identify too many of the answers, but this forklift doesn't appear to have a rating for use in hazardous locations, which would be an EE or EX sticker on the side of it. So for that, the forklift, all of the forklift itself is quite the ignition source hazard.
All right, so Alysha, if you can, I'll let you use the annotate function, and why don't you circle some of the things that you see in this particular image here?
So this is what Adam was just saying. It's a really great reason of why we partner and work with other companies on these DHAs and stuff. So from my perspective on the dust collection side of it, I wouldn't have thought to immediately look at that forklift. And I don't think I would have known that it wasn't for a combustible or a hazardous environment. So that's really great information to know. On my end, of what I see that I would be worried about is that it seems like there's a lot of buildup. There's a lot of particulate buildup on the ground, as you can see on this piece of duct up here. That is all hazardous. That's particulate that if a pressure wave were to come through or something was to happen to knock it off, you would cause that cloud, that dispersion of that particulate into an area. And let's just say this forklift did cause a spark, that could cause a flash fire or cause a more serious explosion. So from what I can see, especially when we're looking in a facility and you look through rooms or you look at lights, you kind of look at these hazy atmospheres to kind of see that you're not controlling the dust in that area very well.
Mm-hmm.
Those are some of the things I noticed. I mean, from looking at this duct work, which is another thing that we often take a look at, is how is it sized? Is it conveying at the right velocities? These are proper fittings and proper branches. That's always a good sign, but we would need to confirm that we were conveying that material properly and we didn't have any buildup not only on the outside of that duct, but also inside that duct.
Alysha, that very good actually. I was impressed. You noticed the buildup on the angle piece right here. I don't know if you saw these two circles that I just did.
No.
Yeah.
Oh, did we?
In the middle on that light beam. I don't know. I didn't get control. I just annotated.
Oh, okay.
Okay.
I didn't realize that was you. The last two that were there.
So,
okay.
Alysha, very good. I also look at how light bends and what it reflects and refracts off of. So you can see that haze in the background. And it's really tough to see here. But that buildup, when I do a DHA, I look up a lot because these are horizontal overhead surfaces that naturally are going to collect dust. And they're hard to reach typically, which means they don't get cleaned as often as they should. And Alysha brought up a very good point, that pressure wave. It's not even, let's say this forklift gets a nice little pop or sets off a little fire around it. Well, that's one part of a hazard. But if this dust cloud is in this entire room, that little spark is going to spread throughout the room, throughout the building maybe. Or if a motor is overheated and it pops and shakes the room, all this dust is going to sprinkle down and cause what's called a secondary explosion, which is when that flame or spark just starts reacting with all those particles and spreads throughout the building, and that's how you blow a roof off. So very, very good observation.
Is there anything else that is in here that we could point out?
I mean, those were the most things. I mean, without identifying what's going on in the equipment and where that dust collection line goes, I think you identified the buildup, housekeeping, and this electrical issue.
All right, let's pull another one in here. Let's pull this one in here. I'm going to hand this one over to Alysha here. What are some of the issues? What are some of the potential F-bombs, those filter bombs that we see in this image here? This is an image of exterior shot with 2 different dust collection systems.
Yeah, so this is something we really commonly see. So let's just say a customer purchases a dust collector and installs it in their facility, and everything's all fine and dandy until they do a dust test and they realize that it's combustible. And the great thing about dust collection nowadays is that a lot of dust collectors have the ability to be converted over to an NFPA compliant collector very easily, or at least somewhat easily, depending on the one. In this particular case, this unit, very easily, they just remove a side panel. They would put that explosion protection on it, this vent right here. But what they haven't done is protected down here. So they haven't put the rotary airlocks or protections on this drum. That just looks like a drop connection down to a flex hose, and that's definitely a risk. So this happens a lot, especially when customers don't complete that DHA, is they don't get the full picture. They think, oh, I need a vent. Awesome, I'm putting a vent on my collector, but there's more steps than that you need to take to protect from an explosion. So in this case, this customer would need to go back and also add that rotary airlock. I can't really see up here, but I'm hoping there is a isolation valve or a return valve so that this flame front couldn't go very far. I'm going to assume it's somewhere over here, but not really sure. But that's kind of what I would.
So those are very good points and accurate. And is also with what you circle down here is, so I look at this a lot when I see, especially flex down to a covered drum, is to verify that the drums are still bonded. So I look at bonding grounding programs and PMs during my DHAs. So if you're going to attach this drum, make sure that that flex has the metal coil running throughout it so that it bonds the drum to the dust collector, which should be grounded either through the grounding rod or through the facility. So that's one of the other aspects I would. This one does have an isolation valve on the roof, so impossible to see pretty much. But I actually wanted to show you this panel itself and where it's directed. This is, an area of heavy vehicle traffic, including semi-trucks unloading material. So if that blows and there's a truck passing by, it's pretty much going right into the cab. And this is something like that example I used earlier. This is just one demonstration of, okay, they just bought a dust collector with a panel on it, but where's the panel going? This is, I would say, one of the biggest faux pas we see is direction, that you're directing a blast specifically to that area with the panel. So there's a few options. They could move it or re-engineer it, which is tough. They can put what's called a deflector plate on it, which just it has calculations based in the standard. So if this blows, it's going to direct the flame front kind of up. So this, if it blows, it's hitting some vehicles. There's forklifts there all the time. So besides all the great things you identified, that was something else I saw.
Yeah, that's a really good point too. Those zones are not we often get comments like that. Well, I've put, we've tried to direct traffic around it, or we've done this or we've done that. And it's like, that's not really an option. That is your explosion zone. And if
Yeah.
you're not comfortable, or if you don't have that ability to keep that zone clear, then you have to do the other
Right.
steps.
And with this panel, I've been seeing it more and more that people will put panels on it. And when I ask, well, who put the panel on? Whoever did it, whatever firm, or if they bought it that way, I'm like, okay, well, especially if there's no isolation, does this panel allow for venting of the entire ducting? Because all that volume kind of needs to be taken into account in some aspects. So
I'm glad I pulled this in. I mean, this is something that I think we can continue a lot in these sort of
yeah,
in this material that we cover, because in every single picture we can help folks identify things. I mean, and you're doing this on a regular basis in all the analysis work that you're doing. We've got one last photo here, and that is this one here.
it's my
So.
favorite.
Yeah, I think this is actually you in this
That is
bucket
me.
up here. So you can't answer this one.
Okay.
Alysha, we'll have you go first, and then I'll go, and then we'll hand things back over to Adam.
Okay, so sometimes looking at these pictures was a little like, what were those, like I Spy game?
Mhm.
You know, you're like
Yeah,
trying to look through a
that's
bunch.
exactly.
So the first thing I would notice is I look at the lights. So we'll go back to that concept of, if you're kind of getting this haze, you're not able to see through your facility, you're really not controlling your dust problem in your facility. And anytime that happens, any type of flat surface is now going to become a shelf for particulate and possibly explosive particulate. So that would be a big one here. I think this is a ducted system, but I can't really tell, and I'm not sure what it's ducted for. But I would definitely want to check what's in there, make sure the velocities are okay, everything's running properly. And then, as we see Adam over here actually brushing dust off of one of those surfaces to collect and test, but that's kind of what I see here.
Yeah, he's probably. It looks like there's about as much dust on those surfaces up there as that snow on that tree in your background.
Yeah, probably a couple inches.
So, and a lot of these photos actually came from Adam, but I mean, what do you think, Adam?
So that's exactly it. I wanted to. So this is at a forging plant, metal forging. I think they create metallic silicon, and it was an interesting facility. I find this a lot with foundries and forging facilities, that their rooms look like this. It's how they look. But this is a facility. They always said, their doors are open enough. But as we can see from these hazes, there is no central dust collection. They have dust collection, as you can see from the piping. They have dust collection on some of their equipment, but so this is actually this picture was taken while someone was standing on a mezzanine. This is 3 stories up. Below me were pools of molten metal, and then one room over were giant electrodes. So all you need is the dust concentration. I think the MEC, minimum explosible concentration of the dust, was pretty high. So with data, this appeared to be okay. But what if this connection valve? What if this flange blew off, or the boom lift I was on, popped open this vent? You're going to get a lot of dust very quickly in there, and all of a sudden now you have an explosible concentration or hazardous atmosphere. So, it only takes, from what this could be as considered an appropriate atmosphere, it doesn't take much for it to go wrong quickly. So it was, the haze in the background is what I wanted to show you on this one.
Yeah, well, and I think that's a theme that we can spot pretty quickly. I guess I just wanted to point out that that's a pretty common theme just with these simple photos. Obviously, the one that was on the outside can't really that was more equipment and what's happening on the exterior of the building. But any light refraction or haze that you're seeing throughout the facility, or how far you can see through a facility, that's just a pretty easy sign that there could be a potential issue there. Obviously, the indoor air quality is bad, but is the dust and particulate in the air combustible? And oftentimes,
and Alysha, you were spot on. The amount of dust I took off of these beams, I mean, we're talking just on, maybe not this one, but I took it off the middle of the building of the beams too. And I mean, we're talking 6 inches, a foot high mound of metal dust. I mean, obviously there's a lot of dirt mixed in, so the dust testing was key for all of this. But you know, what I hear a lot of facilities, one thing I ask is, how often do you do top to bottom cleaning? I mean, where someone gets up and cleans the rafters, and I typically hear every year, but that's assuming it's done properly and done every year. I recently did a facility that, due to COVID restrictions, they're understaffed and they work all the time. So their days off for cleaning just haven't been done in a while, and it looks like this, just a different material and a different facility. But you know, housekeeping is extremely important.
Housekeeping! Please go away. Let me sleep, for the love of God!
Just like all safety, housekeeping and preventative maintenance, those are your day-to-day and weekly tasks to prevent a small leak from becoming a big hazard.
Yeah, and I've heard you talk about that multiple times through many DHAs, but sometimes I think facilities will hear like, hey, you have this haze or you have this particulate buildup all over your facility, and they're thinking, oh, that means I need to get this huge dust collection system. Well, it could mean that, or it could just mean you need to up your housekeeping and you need to take care of those areas and just maintain them.
And again, it goes back to the design of the dust collection systems. I see it a lot where the dust collectors just aren't being utilized properly or efficiently, or they're overworked or oversized, and people don't want to use them because they either are sucking too hard or not hard enough, or I've done some DHAs with you guys where they have these giant dust collectors, which are completely old dust collectors. I think before the RoboVent ones got there, I looked at their old system, and they're pulling from just an arbitrary amount of spaces, and it's not adequate. I think there was one, I even threw powder at the vent hood, and it's like it didn't collect anything. So
you just have it in your pocket and you just decided to throw it?
No, I was at the facility. It was in like a mixed lab, so they were mixing the powders in front of these vent hoods. They had 12 mix stations. Only 3 of them had hoods that went to 2 dust collectors on the mezzanine above that were in the middle of the mezzanine with a 90-degree elbow going into it. I was like, none of this. This is not how you collect dust. So.
And that happens so often.
Mm-hmm.
Just either facilities inherit a dust collection system, or they have one from the past and they just keep adding to it, subtracting to it. They don't take into consideration that full picture. And it's just so important when you're talking about dust collection to really understand exactly what your system's doing for you and not doing for you.
Yeah.
Yeah, this has been honestly a really great episode. I mean, there's so much to cover within this particular topic. We're going to continue to cover combustible dust. We're going to cover fire suppression. We've got great folks on staff. We've got great resources and partners and folks like yourself with CTI, Adam. And I really appreciate you both coming on the episode and allowing our audiences to learn a little bit more what some of the telltale signs are and have a little bit of fun in the process. It's great to hear from our experts, and I appreciate you both making the time to do this with us today.
Yeah, thanks for including me.
Yeah, of course. Thanks for having us.
Sure. I'm going to go ahead and end things here. Everybody, thanks for listening, and we'll see you next time.